Alright, the past couple days we have talked about different methods that we can use in order to solve a system of equations. We're going to take all that we've learned and we're going to apply them to real world situations. Most of the time in the real world, you don't have just one problem. You've got multiple variables that you have to account for. So you have to take these multiple variables and use them to set up a system and then solve them. So our first example is we've got a health food store and it mixes granola that's going to cost $4 a pound and raisins that cost $2 a pound together to make 25 pounds of raisin granola. So you're creating this raisin granola mixture. How many pounds of raisins should they include if they want the mixture to cost $80? So this is a common problem. You go to the grocery store and you've got so much money to spend and you've got to make a certain mixture of things. So what I do when you have word problems is first figure out your important information. So I know that granola is going to cost $4 for every pound. Raisins are going to cost $22 per pound. I know that we're making 25 pounds of this mixture. And I know that I want my total to be $80. So I have to take all of that into account when I'm making this. The very first thing that you have to do is identify what the problem is. What are you actually trying to solve for? And you can normally find that in the last sentence. And if we look at our last sentence, it says how many pounds of raisins should they include if they want them extra. So what I'm trying to find for is how many pounds of raisins. I've got two variables here. We have to get raisins and we have to get granola. So step one is to identify the variables that you're going to use. So I'm going to let G be the number of pounds of granola, and you have to be very specific. What about granola? It can't just be G is granola. What about granola? The size of the granola, the color of the granola, there's different kinds of granola. No, what we're talking about is how many pounds of that granola we are buying. And R is going to be the number of pounds of raisins. Again, it can't just be G is granola and R is raisins. If you do that, you're going to get a point off. So we have our two variables. Then we're going to use our information that we were given to write two equations. I always look for two totals. As I read through, there's two totals that I'm given. I have to make a total of 25 pounds of the granola, and I know it's going to have to cost a total of $80. Whatever my totals are, that's what I'm going to set my equations equal to. Generally, not always, there's an equation for quantity and there's an equation for cost. Again, not always, but normally. So I have to think about how am I going to get that 25 pounds? Well, I only have two ingredients. I have pounds of granola and pounds of raisins. So G plus R is giving me 25. I don't know how much G, I don't know how much R, but I know when I add those poundages together, I should get a total of 25 pounds. Now I have to consider cost. Money normally is all in one equation. If I'm trying to spend $80, I think how much does granola actually cost? Well, granola is costing $4 for every pound. And I underlined that raisins were costing $2 a pound. So it's 4 times G. $4 for every pound that we're buying. $2 for every pound of raisins. So first step is to identify your variables. Your second step is to set up your system. Your third step is to solve the system. We've got G plus R is 25. 4G plus 2R is equal to 80. You have lots of ways. You have graphing, you have substitution, you have elimination, you have determinants. For word problems, you get to choose any method that you want. I will never dictate which method you have to use. You just have to show your work. So if you solve by graphing, you better have a graph on your paper. I personally find elimination to be the easiest when I have integer values. So what I'm going to do is I'm going to eliminate the r's. So I'm going to multiply the top equation by negative 2. So I get negative 2g minus 2r is equal to a negative 50. Copy our second equation down. 4g plus 2r is equal to 80. We didn't change that second equation. A negative 2 and a positive 4 gives me a positive 2g. A negative 2 and a positive 2. My r's cancel. A negative 50 and a positive 80 gives us 30. We divide by 2, and we find that g is 15. That's part of my battle. Now what I have to do is I have to find r. So I go back to one of my original equations, and I know that g plus r is 25. Well, I know g is 15, therefore r is 10. Once I've solved for my variables, I refer back to the question, what am I trying to find? In this case, I'm trying to find out how many pounds of raisins. So your very last step, step 4, is to actually answer the question. So you can't tell me R is 10. You have to tell me that you need 10 pounds of raisins. Again, that fourth step is to actually answer the question that was being posed to you. We've got a real world situation, so we don't just have X's and Y's. We have these variables representing things, and you have to say what those things are. And that's it for the first one. Let's move on to our second word problem. We have Alfred has $22 in his wallet. He has $10 bills and $5 bills. If he has $155, how many of each bill does he have? So again, you may want to pause this and reread the question again, really absorb the information you're given, and think about what you have to find. So I kind of underline things. I know that there's 22 bills. He's got 10s and he's got 5s. He has a total of $155. And then my question, what I'm trying to find out, is how many of each bill does he have? Remember, the question is what's going to tell you what your variables are, because your variables are your unknown. The variables are what you're actually trying to solve for. So how many of each bill? That means I'm solving for the number of each bill. And in this case, we've got 10s and we've got 5s. So I'm going to use T, my first step, identify my variables. T is not just going to be 10s, it's going to be the number of $10 bills. And then F is going to be the number of $5 bills. Alright, now we need to come up with our system. We've got two totals. He has a total of 22 bills, and he has a total of $155. So we've got quantity and dollar value, two different totals. If he has a total of 22 bills, well, T is the number of 10s, F is the number of 5s, so if I add the number of 10s and the number of 5s, I get a total of 22 bills. Now I want to do total cost value, or total amount of money in your pocket. Well, 10s, I think it's pretty obvious that 10s are worth $10 and 5s are worth $5. So you get $10 for every $10 bill you have, $5 for every $5 bill. You've got your system. Alright, now what I want you to do for step 3 is solve your system. So press pause, and I want you to solve this using any method that you want. When you are ready, press play and see if you got the correct answer. Also try answering the question. Alright, let's see how you did. For step 3, again, I used elimination. You could have used substitution or graphing or determinants. Or if you use elimination, maybe you eliminated the T's instead of the F's. It does not matter. What matters is that you were able to get that T was 9 and F was 13. So double check your work if you did not get T was 9 or F was 13. Since T is 9, we've got to answer that question, and the question was how many of each bill does he have? So Bill, oh, we don't have Bill, we have Alfred. So Alfred has 9 $10 bill because T was representing the $10 bills, and he has 13 $5 bills. So make sure that you take those values of your variables and tell me what they represent. You can choose whichever variables you want. You don't have to use T and F. You could have used X and Y. You could have used A and B. So you don't have to have step 1 be the same. Everyone's step 1 can be different. That's why you have to define what your variables are, because you can use whichever variables you want. Alright, let's move on to our fact page, number 3. For number 3, what I want you to do is read it very, very carefully and see if you define your variables and set up your system. Once you've done that, press play and check your work. Because the hardest part is getting that system set up. Can you set up the equations? If you can't set up the equations, it doesn't matter if you can actually solve the system. That's not the point of these problems. The point of the problem is to problem solve through and be able to take a situation and think through the situation and set it up so that you can actually solve and get a correct answer. Alright, let's see how you did. As I went through again, I underlined the important information so that I can keep it clear for myself. Use my variables as M and B. I like to use variables that represent the situation, that way I don't confuse what X and Y is. So M is the number of mowing hours and B is the number of hours babysitting. If you just had mowing and babysitting written down, again, you would be marked wrong. What about mowing lawns? The size of the lawns? What about babysitting? How many kids you have? No, we're talking about how many hours did you spend mowing these lawns? How many hours did you spend babysitting? So you have to be very specific when you define those variables. We were given two totals, total number of hours and total number of money. So I wanted 200 total hours, 13 total dollars. 200 hours, so I'm talking about however number of hours mowing and however many hours babysitting has to be 200. As I read, even though babysitting comes first, you've got to make sure that the numbers are corresponding to the correct variables. That's why I like to use M and B for mowing and babysitting. Babysitting is costing pays $6 an hour, so I'm going to make sure that 6 is going to go with the B. And mowing the lawns is $8 per hour, so I'm going to make sure that 8 goes with M. So it's $8 for every hour mowing, $6 for every hour babysitting, and I need that total to be $1,300 of money earned by the end of the summer. Alright, next step is I want you to solve this on your own. Again, you've got to make sure that you can get these skills on your own. Solving a system, review from Algebra 1. We've reviewed it for the last couple days. I want to make sure that you can get these systems solved for on your own. I'm going to use elimination. You can use whatever method you want, but if you want to be able to check your work in case you made a mistake, step 3 when I show it is going to be done in elimination. So press pause and press play when you are done. Alright, let's see how you did. Again, I used elimination. I eliminated the B's. I tend to use the smaller the two numbers, that way my numbers stay smaller. The larger the number, sometimes the harder they are to deal with. And I end up with 2m equals 100 and m is 50. I plugged it back into the simpler of the equations, it doesn't matter which one you use, and I found that b was 150. So once you find your m and your b, you've got to make sense of it. You've got to actually answer the question. The question was, how many hours should you work at each job? So in order to work only 200 hours and get $1,300, you must do 50 hours of mowing lawns and 150 hours of babysitting. Alright, we have one last problem left. This one is a little bit different, a little bit more difficult. So again, I want you to read through it very carefully and see if you can define your variables and come up with your system. Once you're done with that, press play. Alright, this one was definitely different. As you read through it, what we were trying to solve for is how much do one cube and one cone weigh. So, in order to do that, we have to find out how much one cone and one cube weigh. So I've got to find the weight of a single cone and a single cube. In this case, I used x and y because they both were, cube and cone were both c, and you don't want to use the same variable. You've got to use two different variables for two different things. So we've got the weight of one cube being x and the weight of one cone being y. As we read, if 2 cubes and 1 cone weigh 15. So it was less obvious that our total in this case was 15. It was 2 cubes, so that's 2 x's, plus 1 cone, which is 1 y. So 2x plus y is equal to 15. And 3 cubes and 2 cones equal 24. So 3 cubes is 3 x's, 2 cones is 2 y's, and a total weight of 24 pounds. Alright, I'm sure you can guess at this point. I want you to press pause and see if you can solve your system and answer your question. Alright, let's see how you did on the last problem. Again, I used elimination. You could have used any method you want. I found that x was 6 and y was 3. So what that means is x was the weight of 1 cube, so 1 cube is going to weigh 6 pounds, and y was the weight of 1 cone, so 1 cone is going to weigh 3 pounds. What you have to do is make sure that you take that information to actually answer the question. We want to find out how much does 1 cube and 3 cones weigh. 1 cube is 6, 3 cones, well 3 cones at 3 pounds is 9, so together they weigh 15 pounds. Hopefully, you did not stop here and you actually went on to answer the question. So make sure that you reread the question and make sure that you've actually answered what they were asking for. All right, and that is it for our word problem notes. Make sure you have these down.